This is a video about rate of change and slope. Rate of change is a measure of how two quantities are changing in relationship to each other. For example, on this graph, which shows the amount of water in a pitcher after 9 a.m., you can see that right at 9 a.m. when we're starting, the amount of the water in the pitcher is 60 ounces. But then, as the day goes on, it looks like maybe someone drinks the water, and then someone fills it back up, and then someone drinks some water, and then things stay the same, and then maybe someone drinks some water, so it goes back down. So for rate of change in this first hour, you might say that over the course of 1 hour, the amount of water in the pitcher decreases from 60 right here to 50 right here. So it's gone down 10 ounces in 1 hour. By definition, rate of change equals the change in the dependent variable divided by the change of the independent variable. So, for example, in this first hour, we go from 60 down to 50. So that's negative 10 ounces. And we go from 0 hours to 1 hour. So that's positive 1 hour. So we're talking about going from left to right. So we would say the rate of change is negative 10 ounces per hour. However, if we looked at a different hour, maybe the hour from 2 to 3, we would see that the water in the pitcher went from 25 right here all the way up to 80 right here. So in that green hour, we would say that the rate of change was positive 55 ounces over 1 hour. So this rate of change was, instead of down 10 ounces in an hour, we're going up 55 ounces in an hour. So a very different rate of change. However, if we look at another graph, we'll see that rate of changes don't always have to be different. In this graph, which shows hurricane evacuation, so the number of people that are left in a particular place after they start getting evacuated for a hurricane, so it's going down every hour, we can see that the rate of change looks something like this. When we start, we're at 1,600 people. And at this next point that's nice for us, we see that after 3 hours, there are 1,200 people left. So the change in our dependent variable, so the people remaining, it's going from 1,600 down to 1,200. So it's going down by 400 people. And that's happening over the course of 3 hours. So that's in this blue section right here. However, if we keep going, say maybe from the 3 hour mark to the next point that we have, the 6 hour mark, here we're going down another 400 people, and that 400 people are getting evacuated also in 3 hours. So over the course of the time graphed here, we have a constant rate of change. And in fact, the reason this happens is because this is a linear function. In linear functions or straight lines, the rate of change from one point to the next has to remain constant. Otherwise, it would not be a line. It would be something jagged like we saw in the water pitcher graph. So this is something super important to know. In a linear function, the rate of change is always constant. So if you calculate the rate of change between any 2 points in a linear function, you should always get the same answer. If you don't, it's a problem. So now we're going to talk about calculating the slope of a linear function. The slope of a linear function is a measurement of its rate of change. Another way to think of this is how steep is the line. And we are going to learn 2 ways to calculate the slope of a line. The first one is by using what is called the rise and run of the line. The first thing that you're going to want to do anytime you look for slope is to identify 2 points to use as your reference points, just like we had the points on the hurricane graph. And you want to use ones that look like they go right through nice points on your graph. So I'm thinking we use the y-intercept of this line right there, and I'm thinking we use the x-intercept right there, because it's easy to tell what those points are. So earlier, I said that the rate of change was the change in the dependent variable over the change in the independent variable. So for us, the change in the dependent variable means the change in y. And that's what we refer to as the rise. So if I start at we're always going to start at the leftmost point. So we're going to say we're going to the right. So that means we're thinking left to right. If I start at the leftmost point and I think of the change in y, from here up to here, we're going up 3. So I'm going to say that my slope is 3 on top over, I need to think about the change in the independent variable, so that's the change in the x. And we're going to think of that as the run. So from my leftmost point to my rightmost point, as I go that way, I'm also going over 3. So my slope is 3 over 3, and you're always going to want to reduce your slope. So to 1. So we would say that the slope of this line is, so the rise is going up, the run is going to the right, and you always start with the left point and then go to the right point to calculate. The second way to calculate slope is to use a formula. So the formula goes like this. If x1 and y1 and x2, y2 are 2 points on a line, then the slope is, and first of all, I need to mention that m is the variable that we use for slope. So whenever you see m, you can assume. So to calculate slope, you need 2 points. So from your graph or from some given information, you want to figure out what your 2 points are. And so in this case, I would use the ones that they have marked for you on this graph, -3, 1, and 3, -1. So I'm going to write those down, and I would suggest that you always do the same. Now, what you need to do is you need to mark your x's and mark your y's. So x1, y1 means the x and the y of the first point. So it tells you that that x and that y go together. And x2 and y2 means the x and the y of the second point. So this is just telling you that the 3 is the x from the second, the -1 is the y from the second. And from there, you want to plug into your formula. So you say m equals y2, well that's -1, minus y1, that's 1, over x2, which is 3, minus x1, which is -3. And what you want to be careful of here is your negative signs. This number is 3, there's a minus from the formula, and then there's another minus from the number. So on top, -1 minus 1 is -2. 3 minus -3, that's going to be a plus. So we have 3 plus 3 is 6. And then you always want to reduce. So I can reduce this to -1/3. So we would say the slope of the line pictured is -1/3. Now that we've seen the two methods, we're going to use them to calculate the slopes of vertical and horizontal lines. So we'll use one method for each of them. So for this vertical line, we're going to use the rise and the run method. And we're going to use the points that they have marked, 0, -3, and 0, 5, to calculate our rise and run. So I'm going to just write down to remind myself rise over run. And that's going to be equal to m. So the rise, as I go from -3 down here to 5 up here, if I count, that's 3 up to the x-axis and then another 5, so that's 8. So it goes up 8. Now for the x's, I'm not going over at all. I'm starting at 0 and then I'm not going over. So that means that the run is actually 0. So I have 8 over 0. And when I have 8 divided by 0, you can't divide by 0. So what we need to say is that the slope is undefined. So, and it actually turns out that the slope of all vertical lines is undefined. So you should write this down in addition to saying that this is going to be the case for any vertical line. You can automatically say that its slope is undefined. Now, for our second problem, for the horizontal line, we're going to use the slope formula. So I'm going to use these 2 points that they have marked for us. And the first thing I'm going to do is mark off x1, y1, x2, y2. So then I'm going to do my formula. So it's m equals, y2 comes first, so that's -4, minus y1, which is -4. So I have to do -4 minus -4. I'm going to have that double negative in there. You should be careful. And then x2 is 4, minus x1, which is 0. So on top, I have a negative negative, so that makes a plus. So negative 4 plus positive 4 gives me a 0. And then on the bottom, I have 4 minus 0. Now 0 over 4 you can do, unlike when 0 is on the bottom. When you divide 0 by anything, the answer is just 0. So we would say the slope of this horizontal line is 0. And like with vertical lines, the slope of a horizontal line is the same all the time. It's always 0. Vertical lines are always undefined. Now that we've seen the slopes of 4 different lines, I want to do a little summary. If you have a line that is going up as you go left to right, because with slope we're always thinking left to right, that's going to have a positive slope. So the first line that we looked at went up from left to right, and so its slope was positive. If it's going down from left to right, that's going to have a negative slope. And so the second line we looked at did that. Its slope ended up being negative a third because it went down. Whenever you have a horizontal line, you're going to have a 0 slope, which we just saw. And whenever you have a vertical line, you're going to have an undefined slope. You want to know these 4 things and be able to always say the slope based on the picture. So make sure you have all of this in your notes, and we're done.